Hey, good morning everyone. My name is Yuri and we're gonna do live coding today. So let me know if everything is alright with the visuals, with the sound, and meanwhile I'm gonna be opening some Prosecco. And I'll tell you a couple of animational stories today. A couple of different ones, a couple of surprises for me. I'm just waiting for the chat because there's this delay. I wonder if there's a way to remove this delay between streaming and the chat part. Good morning, everyone. So you can already see the website in the background, which we're going to be trying to replicate today. Hopefully it's going to be cuts a little bit real. Maybe I wasn't speaking loud enough. I can actually move the microphone a bit closer. Maybe this way it's going to be better. Maybe this way it's going to be better, hopefully. So I got some Prosecco, and let's get started. Yep. Can you? I'm not sure if you can hear the sound of Prosecco. Alrighty, let's switch the screen and let's get started. So this is going to be the website. And the nice thing about the website that when I started learning like how it's done, I realized it's done with the GPU technique, or FBO, like frame buffer output technique. And maybe it's a good time to try this technique because the Three.js has an example on that, and we can try to do this with this example. There are going to be a couple of surprises though. Maybe we'll try to figure out whether they are surprises, or maybe you'll help me. There's also a couple of other things because a funny story happened to me yesterday. I was trying to decompile a new website for the stream. I found this pretty awesome effect. I already shared that in my Discord, but I'm going to share it with you too. So I found this pretty cool effect. And I knew I've tried to implement this effect myself, like when you press, no, not this effect, but the roll effect. Let me show you the roll effect. So this should have been the stream topic today. Yeah, I just should go to the home page to see the effect. Yeah, it's cool, all right. When you press and when you drag, you could see this amazing roll effect. And I thought, well, I tried my take on this one, but this gotta be simpler. This gotta be cooler way of doing this. And I tried to decompile this effect, and it was so complicated in the code. I couldn't really understand the code because everything has been done in a vertex shader, and there has been a lot of math. And after, I don't know, like 20 minutes, I actually realized that this code is based on my code that I did like a year and a half ago in this article for the code drops. This is so funny. You can't even imagine trying to decompile your own code and failing at that, and then realizing you actually did that a year ago. Okay, enough of this funny decompilation story. So I'm not going to be doing stream about that because I already made an article about that and shared the code. So yeah. So this is the website we're going to try to decompile. I think that we do the particle effect, and then we might do this like curtain effect. And then, what else? Good morning to Slovakia. I hope the denoiser is fine. Is it fine now? And we'll try this like noisy effect for the face, which looks kind of cool. Yeah, let's do that. So first of all, I'm gonna call this one a face. I'm gonna get my template. Desktop face. I'm gonna open the editor. I'm gonna need the editor. So I'm gonna be writing the code. Smart. All right, and then I'm gonna run this. And it's Prosecco time. Yeah, thanks. It was just the microphone was too far away from me. It's all Gucci now. Oh, good morning to India. I'm not sure if it's morning in India. It's gotta be late day. Right. So we run it. Let's run this one. And also the nice thing that I think, well, I know this effect is based on this old article by the Nicolas Bardot. I hope I pronounced it right. He's a really cool guy. I once been to his conference speech at the Paris at the Grow conference. He's a real cool guy, and he did a lot of cool projects. And I think this exact post has been an entry point for a lot of people into the FBO, like frame buffer output technique. And not only to that, but to the shader animational techniques as well, because it's dated way back before I even started streaming or learning webgl. And it's a pretty cool article, and explains how you would use shaders to morph some shapes, and then how you would use shaders to do some frame buffer output things. We will be using Three.js for that today, because this one I think it kind of used a different approach, more like native like, but we're going to be using the Three.js for that, because Three.js now has a separate, I don't know, what's that, plugin or library, simple piece of JavaScript that helps you to do exactly this GPU animation. All right, so let's get on to that. So far we have just this. I'm gonna switch it to the, I'm gonna switch my screen a little bit, move things around. So it's gonna be on the right, on the left, and then morning from India, and from Iran on the bottom. Now, yeah, good morning Iran too. And then let's go and start writing some JavaScript. So, make my screen brighter now. Where do we start? First of all, I need in my shader template, which is on Patreon, which I coded a number of times in previous streams. It has another shader, which is exactly for particles. It just differs because it has the point size variable in there. And we could switch the mesh creation here in my template to points creation. I'll remove a bunch of stuff that I don't really need also. I believe so. It's actually kind of weird painting, although all 4 particles are actually exactly the same size, but because of some, Z index game, they appear to be like this. This is something like an art on itself, like, right? So we just make them smaller. I'm gonna see 4 particles, and this is like the easiest way to create a lot of particles. You just create Three.js, any kind of geometry, and you get those particles like for free. Like this, I would get just these because it's gonna be just the particles on the where the triangles are on the shape. All right, so this way we could create particles. I think I could even make them smaller. Right. So the next thing, I could already animate those particles, but the thing is, it's kind of low performant. If you ever try to animate particle systems, you know that the limit is around, I don't know, a couple of thousand particles, and then you have to think about something new because like the CPU is running out of memory. Even if we render particles on the webgl, in the webgl, we are still running low on the CPU because CPU is a bottleneck for all these computations because it's not run in parallel, obviously. CPU just in the loop computes the position of every single particle, and it takes a lot of time. That's like 10,000 of them. All right, so the only way to go around that is to use the frame buffer output technique or so-called GPU technique. And the nice thing, there's already an example, which is called just like that, GPU. This is the keyword you want to look for if you want to learn this technique, which implements a pretty complicated actually example with the birds flying around, and it's kind of might be hard to derive the actual FBO technique from this one, even though like it's really cool demo. But if you just want something simple, it might be not that easy. So let's try to do that. So first of all, I'm gonna just copy some parts from here to make it easier for us, because there's lots of shaders here, like 1, 2, 3, 4, 5, like 5 shaders here. Oh, maybe 4. Anyway, lots of shaders, and it's kind of easy to get lost in there. So first of all, I just need the actual library, because Three.js has a lot of help. How's it called? Computational, yeah. There's a lot of really useful things inside of it, which are not exactly the part of the Three.js anymore, or already, I don't know, but they are still very useful, and it's nice to know all of them. I'm gonna maybe, do I need this? I don't need this. I can do it like this. So I'm gonna, first of all, I'm gonna import this one, and to import something, you just have to Three.js examples, because these are just the parts of the examples, like how you could use Three.js for some different, more complicated cases. That's the most important variable in this whole animation, is the width. That's why it's all caps, because it's important. So let's also use this one. It actually means the number of, it actually states the number of particles we will be using. Not exactly this number, but this number squared, because this is going to be the texture width. And to get the number of pixels in a texture, which is the width of 32, you just have to square that number. All right, so what's next? Next, we should be going and initializing like this GPU kind of stuff. And I'm just gonna go ahead and create this init GPU. And inside this, I'm gonna initialize everything. So this is gonna be the library. No, unfortunately, Lida is not in the Kiev at the moment. Maybe later. Also, it's kind of hard to... it's a dangerous ground to get beautiful girls involved in the shader programming. I don't know. It's hard to do it, like, I don't know, interesting, and if you have any ideas, just hit me. I'm gonna try to do this with Lida. All right, so we have this init GPU stuff, and then we should just initialize this one. So I'm just gonna look for the exactly the initializing stuff, and let's just almost blindly copy this stuff. So I'm gonna initialize GP compute, which is gonna be the width, and I already have the renderer, so could implement this one. There's something for Safari, which is I believe wasn't needed for my Safari, and I will not be using this for my stream. There's a lot of stuff being initialized in this part. I only need just a small amount of this. So first of all, I'm going to initialize the position variable. This is going to be this one, because my whole simulation would be about implementing, like, about changing the position of particles, obviously, right? I'm going to be animating this. So creating this one. I actually like the naming approach they took in this example. So this is position variable. In some cases, people name this one as the material, because this is going to be actual, like, kind of material or mesh, because you could see that we're going to be using the uniforms later on. So actually kind of remember this stuff. I'm going to do this position variable equals hey to China. Oh yeah, she did a good job about quaternions. Repeating the subject of the stream, yeah, sure, we're just trying to implement this animation today, and with using the GPU technique. And then there might be a little surprise about this animation in the end. Yay, thank you, Vasilika. All right. So I'm going to implement position variable, and this one is going to be this should be compute, and it has add variable method where we should add something like it's going to be texture position. So the whole approach is about saving the positions of the particles into the texture, not like the usual way that we do this when we compute everything on the CPU, but this time we're going to be saving everything on the GPU, and this is the famous approach about saving all the coordinates to the graphics card instead of using the CPU memory. Yeah, it's a bit complicated topic, you know, it's a bit of an advanced stuff, but yeah, considering the amount of streams I did already on the basic and medium stuff, I think we're kind of ready for this. So for this animation, we would also need another shader, which is going to be actually changing the position. So usually the shaders does not preserve any kind of state or variable. If you change something in shader, you have to be based on the uniforms or attributes, nothing else. You can't be based on the previous state of the shader. And this is the way to be based on the previous state of the shader. That's why it's called the frame buffer output technique, because shader every single time outputs its state, and then on the next run it's using its state. So we also would need the simulation shader for this one, and I think I could just copy it for now from the Three.js examples. It's gotta be called simulation. Okay, all right. Hello. We're gonna do a lot of preparation before we would see anything with this approach. Well, because of the nature of it, it's a bit more complicated. So I think there are two simulations going on in this Three.js example. One is for velocity and the other one is for positions. So it's a bit more complicated example because there are some logic about birds flying around. Some pretty complicated logic, I should say. And this is the actual shader they have been using. So let's create another shader. I'm gonna duplicate this one. Simulation. I'm gonna copy paste this one. There are some UVs. There is a temporary position which is derived from the texture position, which the GPU library will take care of. So this way we are getting the position inside fragment shader, not the vertex shader. And then we apply like something into this position, which I don't need. So we have the position, and then I could just output something like the position which is moved 1,000th of a unit in some direction. So this way, if everything works all right, I should see on my screen a lot of particles moving in the same direction. So this is a really simple simulation shader. And I have to include this one, fragment simulation. Fragment simulation. So we have the shader. I just initialized that one. So we have this position variable. We shouldn't have any errors so far. It's all good for now. I could even output this one just to be sure everything is all right. Yeah, so it's initialized. It has a lot of like methods, a lot of variables. We have only one texture position, which is going to be changing for now. All Gucci for now. When will you release HTML course? I actually already released HTML course, but it's in Russian and it's like here. But it's only in Russian yet. So if you're interested, you could go there. All right. It's not being like advertised yet, but still. Now, where was I? It's a bit complicated topic, hard to lose yourself in the process. So the next thing is we should we should finish the initializing stuff. So we have the we initialized the variable, we initialized this. Okay, then I think we need to add some uniforms, because obviously to move particles we need to add some time, because in future I will be using some curl noise and some more interesting stuff. And to do this, I could do something like this. So it's going to be this position variable, and then material uniforms. Let's just console log this one to see if it's there. So it's an object. It doesn't have any uniforms yet, so I could add some. You could add it in a number of ways, and this is just one way. I believe the same way they used there in the example. And then if I just output this one now, let's see. Yeah, so we have the time variable. I think only the time is enough for this simulation that I need. And the next thing, I think there's something to state about this texture, like this. So which is needed for this animation to work in a good way. Hey, nice to see you too. So we have all the initializing stuff in place, and then in the end, we need to initialize this whole thing. And this is going to be GPU compute init. I think they also catching some errors, like in case it doesn't support something. Yeah, so you might want to catch something bad that happens once you initialize the stuff. Right. So this gotta be it. This is actually it. There's a lot of code in here. We don't really need the dependencies. We don't really need like this separate uniforms. Don't really need lots of those uniforms. We are good to go with this. So it's actually kind of easy to implement GPU. I mean, easy. All right, but there's one important thing also here. We need to, like this DT position. What's that actually? This is some data texture, I believe. Should be the data texture. Yeah, this is data texture, and the data texture is actually the texture that contains data. So we need to fill this texture, because for now it's should be empty. Yeah, it's all zeros. But this is actually these are actually positions of my particles on my screen. Yeah, so we gotta fill this one. And how do we fill this one? I'm just gonna create like fill positions. This is exactly like the way it's done in the examples. I'm just, for the sake of educational purposes, I'm gonna repeat this approach. So we could just do fill positions for this DT position variable data texture. And this was needed for texture as well. All right, so how do you fill this one? First of all, I'm gonna open this texture. So I can log the texture here. It's gonna be the same data texture, but to get to the data, you have to go to this one, then to where was it? Where was the data? Go to the image and then data. So let's array equals texture image data. This is going to be like the array that I need to update with texture coordinates. And then this array has like 4096 4096 things inside. Why that? Why is that? because 32 multiplied with 32 is exactly 1024. But because this is a data texture, each data entity actually has 4 numbers. And this means if I have like 1000 particles, well, for now I'm going to be aiming at this amount of particles. I need to have like 4096 numbers for those particles. So in this loop that I will have here, where I will need to update my particle positions, I need to actually set 4 numbers instead of 3. So it's gonna do the loop, and this is gonna be the error length, and then this is gotta be for gonna be moving 4 numbers on every iteration, and then I need to set something. So these are gonna be the particle positions actually. And then to actually set those, and the last one, which we're not really going to be using, is going to be setting just to 1. So this way, we don't have the array shouldn't be empty anymore. Yeah, it's just has to have a lot of random numbers, and every fourth of them is going to be 1. So far, so good. Do I teach any other courses? Yeah, I have some awards courses. You could go to the awards. I have 2 courses now by me, like this course, and then the Merging WebGL and HTML Worlds course. So these are the 2 WebGL courses that you have on the awards. Just go there. You can buy any of them. One is going to be released pretty soon. The other one is already online for a couple of months. All right, let's continue. So we have something virtual so far. Oh, thank you. Thank you for good feedback. Appreciate it. All right, so we don't really see anything cool yet, right? We just spent half an hour setting some variables, computing something. What I need to do now, I need to run this GPU renderer on every step of the animation, and I need to use this texture somewhere. So first of all, I'm gonna use this position texture here. It's gonna be null. This is my normal kind of material. And then instead of plain geometry, I'm gonna create the buffer geometry. And then I need to have like some exact number of particles in my simulation because I'm tied to this number. So let's use this. So let positions equals new. And then it's going to be width multiplied by width multiplied by 3 because we have 3 positions for each particles. So, and this is going to be until width multiplied by width. I index going to be I, and then position set some numbers, and then let's also use some random stuff. Kind of feels like the usual programming when you write some code and you don't really see anything cool. Not used to this. XYZ. So this way we fill this array with positions. The other important thing, which actually helps a lot, is to have some references. So instead of just using UVs, we gotta have some references here. Because why we need that? Because we need to reference every particle in my shader when I'm going to be deriving its position from the position texture. I need to have some reference to this exact particle. It's got to be some different number. And UVs are actually these kind of numbers to get something from the texture. This is something like the UVs. It's going to be something like the UVs, except it's going to be a little different. So it's going to be two-dimensional, and then like the first one is going to be like the row number, and the other one is going to be the column number. So the first one is going to be the I width, but the column number and the row numbers have to be between 0 and 1. So it's going to be I width divided by width, except that it's all caps. So it's going to be the X, and then the YY, because I used already the X's. Reference, it's going to be YY and XX. So I'm just filling the virtual UVs for my simulation. So this has got to be something else. There's this interesting life hack they used, like this. And this divided by width, divided by width. It's got to be it. Let's just see what's going to be inside those references. So you could see it's starting with 0, 0, then it's something small 0, then it's something bigger 0, etc. And then if we go further, the second, like the odd or even number starts to grow too. So it's kind of UVs. This is how UVs look. It's just pairs of numbers which correspond to some dot position or some vertex position, or like some coordinates in two-dimensional space. And this is exactly what we have here. All right, so we have those references. Now we have to add those attributes to my geometry. So I'm gonna do this geometry. So I gotta have those attributes in my vertex shader. It's gonna be add attribute. I'm gonna call this one position. Buffer attribute, and then the actual array, and then the number of, oh, it's not add attribute, it's set attribute. And then the same goes for reference, except it's 2. Alrighty, so now we have something to show. Actually, it's gotta be different now. Yeah, we have a lot of particles now. I have like 1,000 particles with random positions from 0 to 1 on the screen. Right, and we have some reference. We could even show this reference actually, because in my vertex particle I could add the attribute. It's going to be two-dimensional reference, and then the position is actually already there. And then instead of using this VUV, and actually let's output something. This VUV is being output, but it's all black because it's a particle. It doesn't have any UV. But what I could do here, instead of this, I could just use this. And they're gonna be all like fun because they're all random. They're not really, the colors are also random, but like the colors for now just correspond to the order in which I add the particle to the array, nothing else. But they all have the unique number, the unique stuff which we could reference them from. Right, so this UV or this reference is actually a unique thing. So now just two small steps. It's already mobile responsive, just resize the canvas on the resize. So my template is already mobile responsive. All right, so next, just two small steps left to implement this whole thing. And then we have this position texture. And this is the uniform, which I would like to use inside here. It's gonna be the position texture. And then, like, I could do this. I could do the like free false equals texture. You could also sample textures in the vertex shader now. And you could use this position texture, which is not updated yet, actually. And you could use this reference just to get exactly this particle. And then I could use this position to actually output something like this. It doesn't work yet, probably. Something is wrong. Dimension mismatch. Yeah, because it's three-dimensional. Gotta take X, Y, Z. So it's all good now. It's just the position texture is not updated, and I'm not using this position texture. So now let's update this position texture inside my request animation frame loop. I'll go here. I'm going to do GPU compute. And now I should set my uniform position texture, this one. So it's going to be this material uniforms position texture value. And I got to get something from this GPU compute. Oh my God, Prosecco is starting to kick in. So I believe it's going to be get current target, and then this position variable texture. Because this thing, what doesn't have inside? This is a WebGL render target, so it's not a texture itself, but it has a texture inside. So I should take this texture and set it to my material uniform position texture. And now what's happening? So we have this GPU compute initialized. We have some shader which does something to this variable. And then I could use this variable inside my just usual render loop. Like here, it's just the usual stuff, the usual object. And I could use it to do something. So first of all, instead of position, I'm going to try to use pos, and nothing happens. Because texture position undeclared identifier. Well, because I used the position texture, and then I used the texture position. All right. So it's position texture. And here it's gotta be also position texture. Okay, wait a second. What was the mistake again? Line 97, think post texture position. Why don't I have it? I think I had it. Texture position. Oh, I think the mistake is not in this one, but in this shader. And I have to uniform. Still identified. Face. I don't really need this face. Just the leftovers from the old stuff. All right. It works. It finally works. So what we see now is actually particles moving like with this iteration. And we're not doing anything in the CPU, right? Nothing happening on the CPU. We're not saving the state of the particles anywhere else. We are just using the particles to, we are just using the data inside the graphic card to implement this iteration. And this is actually the frame buffer output. Well, all right, it took us some time, but the code is not really, that hard, right? So in the fragment shader for the visualizing stuff, we just have the UVs showing the different color of particles. In a simulation shader, we just adding some stuff to the position, actually. Just not actually much. We could even get rid of these just this variable. So it's just about getting the last state of the animation and then implementing. So this way they're going to be moving like that forever. And although this exact animation of course could be implemented without frame buffer output, it's actually a big step for the whole humanity to implement this GPU stuff. All right, maybe I'll think about creating this course for the WebGL beginners. Oh, I'm also working on the WebGL, and I'm kind of a CTO in the company, so I do a lot of stuff in the company, like technical kind of stuff. Get into some other projects. Oh, good afternoon to Indonesia. I miss some parts of Indonesia. All right. All right, so we have this animation. It's time to implement the curl noise animation. Actually, we could even take this animation right from the Nicolas Parado article, and we could go and try to do, like, there are sources on the GitHub. I think this is a simulation shader, so we could go into this one. There's a curl noise thing here. Let's take this one. So this one I will be using inside my simulation shader. Okay, now the things should move faster. I'm gonna be seeing something cool. So we have the curl noise here. The curl actually computes us some X, Y, and Z kind of stuff. And I will be using this X, Y, and Z as a speed. So I could actually use it at a speed. So like the what? Target position is going to be, and I'm going to be outputting this target now. From now on, this target position is going to be equal to the old position plus some curl noise. And then I also need the frequency and the amplitude. Like the float frequency equals. I'm from Norway. Oh, I miss Norway too. I miss a lot of countries. I've once been to Bergen and liked it a lot. The frequency is gonna be something like, it's gotta be something small, because all the numbers are between 0 and 1. I think frequency could be like the quite big one. And then the amplitude is gotta be something real small, because all the numbers are between 0 and 1 again, and I need particles to move really small distances on my screen. All right, so it's going to be the amplitude multiplied by this curl noise. The curl returns me a three-dimensional vector. Let's call it f. So it's going to be f multiplied by plus x, f multiplied by y. So now, on every single step, I compute the next position of the particle with the curl noise function. There's one catch also. I think it's timer variable used here, but I have a time, and I also need to set this time inside in here somewhere. I have to update my uniforms. And the uniform time, I created that one. Yeah, it's this one. Boom, boom, boom. Value equals this time, just like that. I'm just gonna update my simulation time as well. Let's see what's gonna happen. Okay, some errors, which is actually nice. Pause undeclared identifier, because it was position. I think it was position. Another error here. Position undeclared identifier. All right. All right. Still some mistakes. Okay, it's gotta be about this. Right. All fixed now. And now we see something with the curl noise. So it's actually the curl noise animation. And we used to have those particles in the square, but because they move with the curl noise now, you could see how they are living their life, partying there. It's actually pretty cool. And then let's make them smaller. Let's make them different. Let's make them black. Set black. Right, so now we have some black particles flying in the air. Now I need some face. I need face. I will be using the face of Gal Gadot, because she's so beautiful even distorted shape might look beautiful. I don't yet have the leader's face. I think I should get one. Right, we have the face GLB, which is just a face. And then what I need. So the starting position of those particles is determined by my texture, like data texture that I create here. Right, so let's say if I divide this one by something big, they're gonna be plain. Still kind of nice, right? It's like the curl noise is always nice, whatever you apply it to. So this is the place where I create my positions. So I need to base those positions on the actual mesh on the face. Let's do that. Let's do that. This loader equals new loader. And then let's load everything. I don't yet have the face variable. I just know I have to create it. Face GLB. Then once I loaded this face, GLBF scene children 0. Let's see what's that. This is some object 3D which has a perspective camera in the mesh, so we have to go deeper. So this is the mesh now. This is the actual face mesh. I will not even be outputting that one. Trust me, it's a face. It's called face GLB. What else could it be? So we have this, and I'll move all this stuff right after I created that one. Then, what else? I could get the geometry of this mesh. Let's get the geometry of this mesh. So this positions like this face pos equals this model geometry attributes. I already know this stuff. Position array. Let's see what's there. Yeah, so it's not this one. I think it's this one. Yeah. So these are the face positions. They look pretty small to me, like all kind of zero-ish. So I think geometry scale 10. Even we don't yet see the face. I already visualized it's gonna be small. All right. So we have this face pose, and now they gotta be somewhere like between 0 and 1. Yeah, bigger than they used to be. And then we have this face pose. So we have an array, like a lot of parts. We have like 14,000 places where we could put the particles. And face number is going to be actually equal to face pose length divided by 3. So this is the number of vertices on the face. And all right, so now we have this number, I have this face pose. Now I could use this instead of the randomness here. I could let's rand equals math floor math random multiplied with this face number. This is number of vertices on the face. So this way we're getting the random vertex on the face. And then instead of this randomness, I'm going to comment this one. I will be using this face pos. And here it's going to be 3 multiplied with the rand like this. It's got to be +1, the next one +2. So this way we're getting the random point on the face right now. Maybe not. You never know. There are no mistakes in here. yet something is wrong. It's not a face number, it's a face pos, obviously. Yeah, I'm just still dividing the stuff here. So now we have the face. We actually have the face. Imagine that. We have the face finally being distorted with all the particles. We're almost there to the funny part of the stream. I think I would also need kind of move this geometry lower, translate, which is that. It's Y. Let's go. It's just translate, I think, right? No. Okay, let it be 0, 0, 5. Let's see what's gonna happen. Wrong axis. Right axis, too big of a number. Yeah, it's gonna get more centered. So now we have this face. Now what I could do, I could actually use more particles here. Like it's way more particles here. I think the actual we don't have enough particles for the. I mean, the face is not detailed enough as a mesh using that many particles. So I think 64 should be fine. Of course, it's still 60 FPS, even though we are animating lots of particles. For now, it's 4,000 particles actually. And we had like 14K particles there, so I could go bigger than that. Yeah, it's better. We could change the amplitude now in this simulation. And it looks weird, right? She's still beautiful if you look close enough, but it looks weird as fuck. It looks weird as fuck. Amplitude maybe like a lot smaller, and it's gonna be slight. It's gonna be distorting slightly. Probably gonna feel uncomfortable about that one. So I think their face has way more particles on it. That's why it looks a bit cooler. But also you might notice right now that actually it looks different. Like even though we kind of implemented the same stuff, and trust me, the code they're using like almost the same that I used at the moment, but the physics and the visuals are completely different. And now we are coming to the funny part of this stream. I think you don't really need GPU approach to implement exactly this animation, and might be also implementing this animation. I think we could get away without it, and let's just try to do that. Like, why not? While I'm there, I want to make particles smaller. Yeah, I think it looks stylish when they're small. And now let's try not to use simulation at all. So first of all, not to use simulation at all, I would need to what to do here. I still need this face as a base. Face as a base. So inside my verticals particles, I'm gonna copy paste the scroll noise stuff. Right. Oh yeah, I just haven't copied everything. So I'm gonna go to my vertex shader. So far working the same way. Now I'm gonna switch this to just the usual position. Just the usual position. And I'm gonna comment this one for now. So the usual position is just a random square in the 3D space. And now instead of this buffer geometry, so I'm gonna just overwrite this one, geometry, this model geometry. So right, back to the face, but now this face is rendered just as a usual face, just the usual particle mesh. And now, inside this, I think I could use the part of that shader. Like they have the Nicolas Bardo came up with this approach with this computation. This is exactly the code that is used on the reference website. And I'm gonna use this one, but inside my vertex shader. So what we're gonna do? So this one, you see, this one outputs in a fragment shader the actual position. What I'll try to do, I'm gonna get away from the GPU at all. I'm gonna just distort my positions with the curl. So let's get to the vertex particles. And then like 3 new pose equals position. Then new pose equals, I'm gonna be distorting the new pose position with something else. So I'm gonna just create this. I'm gonna copy the numbers that I had here, like the amplitude, the frequency. So we're just like not using now GPU, even though we spent half an hour implementing that. And it's a cool thing, and you might use this for a lot of stuff, but let's try to implement this same animation without GPU. Let's see what's gonna look like. Amplitude 001, you pause curl, frequency. It's not frequency. It's just F. And then new pose is gonna be like the position plus this curl noise. So it always gonna be distorted based on the actual face position. Because you could see the problem with that curl animation, the particles never got back to their original positions. Where here they always kind of based on their original position. So that curl noise approach didn't do good to re-implement this particle animation. That's why I'm switching back to the vertex shader. So wait a second. Amplitude, curl noise, and then they also have this this part, which actually kind of adds an easing to the whole animation, but let's also implement this one. So max distance. Let's make it bigger. Make it twice bigger than the amplitude. And so the new position in the end, so we calculate the target position. So it's going to be vec3 target. So this is the original new pose. This is the target. Then we calculate the distance between those, like the target and the original, which is position, just the position. And then raise it to the power of 5. I actually need to move this, like this is the end rendering for me. So I can calculate the target. I have the original. Now I have to calculate the difference between them and divide by max distance. Essentially what it does, if the change is very small, the particle stays at almost the same spot. If the change is bigger, it just shoots to the space. All right. So I'm gonna just overwrite this new position, and it's gonna be something between position and the target. And then let's output this. Fingers crossed, it's gotta do something. Probably some mistakes. Pause and declared identifier. Where did I use pause? Okay, so far so good. Are they moving? I think they are not. Why is that so? Why is that so? Maybe this is way too small or something like that. I'm actually outputting new position and I'm overwriting this new position here. Let's output target. Yeah, so we have this distortion now, but you could see the particles are not really getting away now. And the thing is, like you see with this target, we are not really using this easing approach that Nicolas Baradot used. And this is why the face is just kind of simple distortion. To make it really more noisy distortion, you have to add this part. Not sure where it's gone bad here. Okay, maybe new pose as well. And then let's put this new position. Okay, something is moving. Yeah, you could see now it's a bit more noisy. The frequency maybe could be bigger. You could see it's starting to look more like the original animation. Maybe these numbers gotta be bigger or something. Yeah, you could see now it actually, I think I just nailed it. Of course, they have more particles, but compare this, what we see right here now, to this. Well, they just have more of it, okay. So the frequency gotta be like maybe 30. No, I think 30 is too much. You gotta play with the frequency and with all the stuff, and you would get there. This is kind of it. And all this stuff is now happening on the GPU. This is a nice thing. And it's nice thing we're not really using GPU. So this was my first original idea that for this exact animation, we don't really have to use GPU. We could just get away with using the curl noise distortion and vertex shader. Although it's a very nice thing, and I used this one to approach the GPU animation itself, because it gives you a lot of flexibility, and you might use this flexibility in my next streams. So I already explained this part. You could base it. I have to nail the coefficients. No, it looks kind of already very close. It's just that I don't have enough points to look at cooler. So what I could do here, I could, instead of the face, use the sphere, because sphere is kind of a very rounded face. And then this model geometry where I use it. So instead of this, I can do not enough. And I think we might get the particles a bit bigger. And then get in there. Now it's kind of this noisy approach. And then, yeah, exactly. Subdivision modifier might help here. I just don't want to overcomplicate things. So this one is a free subdivision modifier on the icosahedron. And then maybe even bigger than that. So now it's kind of that like this, right? It looks like this, but you don't really need the FBO approach to use this one. Although FBO approach opens up lots of possibilities for you. And what I could do here as well, let's use the black background. Oh no, we forgot one thing. We forgot the thing with the curtain, like this. So the funny thing about this curtain, I think the original approach was to implement the div. So it's a DOM element, the black one, which covers half of the background, and then also to implement this part in the webgl, I guess. That's what I suspect. But let's try to do it my way. Background black. If you watched my previous stream, you could actually guess what I'm gonna do now and how I would implement this effect with just one line of code. So like this, we have the we have it covered. But what we could do here, doesn't do anything, but we switch to white. It's gonna be exactly the effect, because the mixed blend mode does exactly that. It just inverts, well, it's difference. It's exactly the difference. And the difference between white and white is 0, that's why it's black. And we have this, and we could just, I don't know. We could get the mouse position on the screen and then set the height of this element. So we could do this. Let's, the last thing, do this. And also we could change the frequency, I guess, maybe to 2. Gotta be more noisy. I think it's more beautiful like this. But what I also wanted to do originally, I wanted to create the black background. Hey, why did my particles go? All right. What happened? Just change the color, come on. Oh yeah, because the particles are black and the background is black, I don't see anything. Bug of the year. The ABs. That's true. Exactly describes the situation here. Fragment shader, I gotta make them white now. Get away with this. Yeah, it's white now. But now it's gotta be something else. It's not gonna be difference anymore. It's gotta be something else. You could do like, no, it's still difference. Difference still works. All right. And to make it look nicer, to make it look a lot nicer. Additive blending. And then maybe, well, yeah, you could play with it a lot all day long. It doesn't hit for some reason. I think maybe it's way too much particles, not way too many of them. So I use the psychoside run. I think it's even cooler this way. More geometry-like kind of stuff. So this is it. Yeah, this is my take on this. I hope it was educational, and we could always get back to the original one. So if I just command this for a second, and I get back to my vertex, and we just use this pause. So back to the face, because I'm generating it from the face. But it's a completely different animation. I'm using the curl noise now in my simulation shader to like amplify this, to like distort this face, but it's something completely different that we see here. The particles will never get back to original positions. It's going to be a different animation. And actually, yeah, you don't really need it's funny in a weird way. Still beautiful, right? Still beautiful. I can make anything out of this, you know? Make anything out of anything with these particles. So yeah, actually it's one stream, but 2 different approaches for 2 different animations, for 2 different technical stuff, and then the mixed blend mode on the top. So I hope you like this one. It's a pretty cool thing. It's always nice to see a lot of particles floating in the space. You just build this curtain. So I think I gotta stop at this point because I already did a lot of stuff here. It's like 2 animations. The curl noise animation and then the GPU animation. And I hope this stream will be educational. to someone who's going to be trying to get into this one, and maybe inspiring, because it's not that hard to get into the GPU actually, as you've seen. It's just actually, how many lines of code? It's just this. I mean, they're kind of complicated, but not as complicated as you might expect them to be. So yeah, guys, hope you liked that one. If you have any ideas what you would like to see in my next streams, what you would like to hear in my courses, just let me know. I really appreciate all the comments. The comments are helping videos to be, in the search results or something. So please comment and please like, or if you like this kind of stuff, subscribe. You can also support me on Patreon, and thank you everybody for supporting me on Patreon. This is the biggest support I ever had on Patreon. I'm saying this like every new stream now, but it's true. I get more and more supporters, and it's really awesome. It means some of you like this, so just let me know all the feedback, and everything is there to say about me and my streams. Yes, it exactly looks like Gal Gadot, so a couple of Proseccos. I mean, she still looks beautiful, right? Yay, thank you guys. So I'm wishing you a great day. Say something kind to the people that you love, do something good, do something inspiring, create something, inspire yourself, inspire people around you. I hope you had some fun this stream. I definitely had some. I will be having some more this Sunday. And I'm wishing you a great day, and see you hopefully in a week, maybe not, I don't know. It's follow my announcements on Twitter, or what's that? Click that bell under the streams to get notified for my new streams. And yeah. If you have some questions, I'll stick in the chat for now. Yeah, it's definitely looking like Gal Gadot. I'll be sticking in chat to answer them. Otherwise, have a great day, everyone. Love you.